Okay, today we're studying partial fractions, which is a really convenient way for us to integrate some very difficult functions that may not look difficult to begin with, but they're very, very involved. After today, you need to be able to decompose rational functions into a sum of partial fractions of linear, repeated linear, linear quadratic factors, and then we're going to have to integrate this sum of partial fractions. Now, the first one we're looking at is the integral of 1 over x squared minus 5x plus 6 dx. There is no u substitutions for us to make. We could sit here and try u equals x squared minus 5x plus 6, but then we're going to get a du of 2x minus 5, and it's not going to work out so well for us. In your packet, there is a method of integrating which is called trig substitution, and as you can see, it is very, very involved, very, very long. So we'd like an easier way of doing this. And it would be much, much easier to take this integral if we knew that 1 over x squared minus 5x plus 6, the integrand, was equal to 1 over x minus 3 minus 1 over x minus 2. Because if we were to integrate these here, these individual ones, well, this is just a simple u substitution, and you're going to get a natural log of x minus 3 minus a natural log of x minus 2, and we're going to be good to go. So that's what today is all about. It's taking something that looks like this and then turning it into these here. All right, so decomposition of n of x over d of x into partial fractions. Okay, you come across a rational function. First of all, you want to divide the numerator by the denominator if it's improper. So if the degree of the numerator is greater than the degree of the denominator, then hey, go ahead and divide. But if not, then what you're going to want to do is you're going to want to factor the denominator, okay, into factors that are both linear and or irreducibly quadratic. So something like x squared minus 2 or x squared plus 4. X squared minus 4 is not irreducibly quadratic because you can factor that into x minus 2 and x plus 2. So we're looking for things like x squared plus 4. Again, because these are irreducible, or this is irreducibly quadratic. This is a linear term right here. This is a repeated linear term, or maybe an x minus 3. Factoring into those. But we don't want to leave anything that can still be factored, like x squared minus 4. You don't want to leave that. You want to say that's x plus 2 and then x minus 2. For linear factors, what we're going to do is we're going to let for each linear factor of the form px plus q raised to the m power, the partial fraction decomposition must include the following sum of m different fractions. And basically, you're just going to take some unknown constant and you're going to put it over your linear factors. If it's quadratic, then you're going to have a different type of linear numerator right there, and we'll be going into that. And it may look like a lot right now, but it's actually quite simple, and we'll get to that here shortly. So here we go. Write the partial fraction decomposition for 1 over x squared minus 5x plus 6. We've already done that, or I've already showed you what the partial fraction decomposition was a couple slides ago, but now we actually want to talk about how to do this. And so what we're going to do is we're going to go, all right, remember, we want to factor the denominator. So 1 over x squared minus 5x plus 6, I know, is equal to 1 over, and then this factors, x minus 3 times x minus 2. Now to do a partial fraction decomposition, I see two linear terms here. I see x minus 3 and I see x minus 2. And so we will have a over x minus 3 plus b over x minus 2. And now what we're going to do is we're going to take this equation right here and you're going to multiply it by the least common denominator of all three terms, here, here, and here. And so the least common denominator in this case is going to be the x minus 3 times the x minus 2. Now we're going to do this the long way to begin with, but after this you can kind of do the shortcut method. All right, multiplying way over here, what we're going to end up with is 1. In the numerator we will have the x minus 3 times the x minus 2, and then we still have our x minus 3 over x minus 2 in the denominator. And pretty immediately you should be saying, oh, these are going to reduce, and I'm just going to be left with the 1. But we're going to go ahead and write these out. So now what we're going to do is we're going to distribute to here. We'll be left with the a and the x minus 3. And then in the numerator, when we distribute x minus 3 and x minus 2. Then we'll distribute to our second term. So we'll have plus b, we'll have the over x minus 2, and then in the numerator we'll have the x minus 3 times the x minus 2. And so, as you're probably saying, well, over here x minus 3 and x minus 3 will reduce, x minus 2 and x minus 2 will reduce. For the term with the a, the x minus 3 and the x minus 3 reduce, and for the term with the b, the x minus 2 and the x minus 2 reduce as well. And so what we're left with is 1 equals a times x minus 2, and then plus b times x minus 3. Now, in future examples, you can jump straight to here. I know that if I distribute my x minus 3 times x minus 2 all the way over here, all that's going to be left with is the 1. Similarly, when I distribute here, my x minus 3's will reduce, and I'll be left with the a and the x minus 2. Distributing here, I can see into the future that x minus 2's will reduce, and we'll be left with the b and the x minus 3. So you can jump straight to this step right here. Now we need to figure out who a and b are, so we're going to choose convenient values of x. And by what I mean by that is, hey, what makes one of these 0? And so in this case, x equals 2 makes this factor right here 0. And so plugging in 2 any place I see an x, we're going to get 1 equals a times 0, because 2 minus 2 is 0, plus b times 2 minus 3, which is negative 1. So that's gone. You're left with 1 equals negative b, and so b is equal to negative 1. Another convenient value for x would have been 3. So we're going to do it again. And so we'll have 1 is equal to a times 3 minus 2 plus b times 3 minus 3. b times 0 is 0, and so a is equal to 1. So all we do with these two numbers here is we reinsert them into our partial fraction decomposition. And so this is where we're getting the 1 over x squared minus 5x plus 6 is equal to a, which was 1, over x minus 3 plus b, which was negative 1, over x minus 2.